Good morning everyone. I am Dr.M.Murugalakshmi, Associate Professor of Chemistry, Standard Fireworks Rajaratnam College for Women, Sivagasi. In this model, today we are going to see about what are the types of organic reactions. So we all know so many reactions are taking place all around us. So what are organic reactions? The reactions that involve organic compounds are known as organic reactions. Okay. So there are 5 main types of organic reactions that can take place. They are as follows. What are they? Substitution reactions, elimination reactions, addition reactions, rearrangement reactions, and oxidation reduction reactions. So there are 5 main types. We will discuss in the coming slides one by one. First one, substitution reaction. We all know the meaning of the word substitution. That is, in the place of one atom or a group of atoms, we can substitute with another atom or a group of atoms. So it is a type of reaction in which one atom or group of atoms is substituted by another atom or group of atoms. We are having so many examples for this substitution reactions. Here we are seeing only 2. One is a nucleophilic substitution reaction, another one is an electrophilic substitution reaction. And I have chosen a very common example for this nucleophilic substitution, which is involved in aliphatic alkyl halides. Just I have taken methyl chloride as a starting material. Here the methyl chloride is having the chlorine as a leaving group. It is attacked by the OH minus, which is a nucleophile. We all know the definition for the nucleophile very well, which is a negatively charged species. So here the nucleophile is a OH minus, which attacks the carbon, which is having attached to chlorine. So here the chlorine is electronegative species, so it is a leaving group here, and it takes away a small negative charge with it. So in the figure you can notice that carbon chlorine bond is slightly broken and the new carbon hydroxyl group, carbon oxygen bond is formed. So we can have a transition state. It is a single step process. So we can notice the transition state here, and after the transition state the product is formed immediately and we are having alcohol as a product. So this is an example for nucleophilic substitution, which involves the substitution of OH minus in the single step reaction. And you can also have other electrophilic substitution reactions. What are they? When benzene is treated with chlorine in the presence of a halogen carrier or anhydrous aluminum chloride, chlorination occurs. See here the chlorine is acting as an electrophile. This is an example for electrophilic substitution, and we are getting chlorine as a product. So further reaction may also occur in this. We are also getting para-dichlorobenzene as a product. So these two are the very simple examples for the nucleophilic and electrophilic substitution reactions respectively. And we will see the next type of reaction. What's that? Elimination. You all know the meaning of the word elimination, that is removing something. So here the organic reaction which involves the elimination or the removal of adjacent atoms is known as the elimination reaction. We should have it in, we should remember the point at this stage. Here the elimination is involved in adjacent atoms. So here we are taking alkyl halide. The best example for elimination is alkyl halide to alkene. In the previous case also we have taken alkyl halide in which the substitution is observed. Here when you change the condition, you take the alkyl halide and treat it with the sodium hydroxide in the presence of ethanol under heating. You will get alkene as a product. Here the alkene we obtained is ethylene. What happens here? Here the dehydrohalogenation takes place. From the first carbon the hydrogen is removed. See here in alkyl halide the chlorine attached to carbon, we can take it as an alpha carbon and the first carbon, and the second carbon is a methyl carbon we can take. So from the alpha carbon the chlorine is removed, and from the adjacent carbon the hydrogen is removed. How they are removed? Hydrogen is removed as H plus by the base that we are adding as a reagent. So what the base will do, it abstracts a proton from the next carbon, that is in the second carbon, as H plus, and what happens, the carbon hydrogen bond is broken and the bond pair is shifted over in between the carbon carbon single bond, and that is converted to a double bond. Immediately, to neutralize the or to compensate the valency, the carbon chlorine bond is detached, and the chlorine, since it is an electronegative, it is removed as a negatively charged species, and from the adjacent carbon the hydrogen is already removed as a H plus. So both of them combine to form a HCl, and that is a eliminated product. What is the main product we are getting is a olefin. So this is an example for elimination reaction. So many reactions, elimination reactions are taking place in organic chemistry. When you take polymers or when you take any supramolecules or biomolecules, here the elimination reaction plays a vital role in biochemistry also. Next one is addition reactions. It is a type of reaction in which more than one molecules combine to form a new larger product. That is what addition. So here it may be a homogeneous addition or heterogeneous addition. So here when a bromine, when you take a bromine and when you add it to the unsaturated olefins, it is a very good example, very simple example. Bromination occurs in between the carbon-carbon double bond. Wherever the carbon-carbon double bond or carbon heteroatom double bond, that is it may be oxygen or nitrogen or any sulfur, automatically the addition occurs. So here in ethylene, the bromine addition takes place and the formation of 1,2-dibromoethane is observed here, 1,2-dibromoethane. Okay. And another example, see here in the next box, the mechanism of the reaction is given for, here we have taken bromine, both the additives are bromines. But when you take hydrogen chloride, here hydrochlorination occurs. Hydrogen as well as chlorine is added in between the carbon-carbon double bond. The addition, it is governed by the another rule, Markovnikov rule. இது எல்லாமே வந்து that we will discuss in olefin chemistry, okay, anti-Markovnikov's rule, Markovnikov's rule, etc. So here if it is a symmetric carbon-carbon double bond, the addition occurs automatically, the chlorine goes to one carbon and the hydrogen goes to another carbon, so automatically addition occurs, you will get alkyl halide as the product. So when it is an unsymmetrical olefin, the addition is governed by, as I already said, it is by Markovnikov's rule. The negative part of the addendum will go to the carbon which is having less number of hydrogens. Okay, that is what the addition takes place. So this is a type of organic, this is a type of organic reaction. What is that? Addition reaction. So all the unsaturated compounds are easily undergoing this addition reactions. Generally in lab also, for finding out the compound whether it is a saturated or unsaturated one, we can do this test, bromine water test, for testing the saturation or unsaturation. So addition is a one type of reaction. And next we will go for the another type of reaction. What is that? Rearrangement reactions. So this is a type of reaction in which the molecule is rearranged to give a structural isomer of the original molecule. I have taken a very simple example. What is that? Pechmann rearrangement of oximes. Here we have taken ketoximes R1 C double bond NOH R2. This is a ketoxime. In the presence of an acid or in the presence of heat or light, the reaction may occur, the rearrangement may occur. So rearrangement takes place within the molecule. Okay, so the product is a structural isomer of the original molecule. So ketoxime is rearranged to form an amide. How? Here the R2, it is disconnected from the carbon and it is migrated to the nitrogen. So what? See, when it is attached over here, the OH minus, it automatically migrates to carbon and that carbon is oxidized to carbonyl carbon, and at the end we will get the amide as a product. So many rearrangement reactions are there. I have taken a very simple rearrangement reactions, Pinacol rearrangement, Wolff-Kishner rearrangement, the madri so many rearrangements are there. Then next we will move on to the oxidation reduction reactions. This is a last type, fifth type, oxidation reduction. We all heard of the word oxidation and reduction. There are certain reactions which involve only oxidation and only reduction. And in some other cases, we may expect both oxidation as well as reductions. Here, we will see what are that oxidation and reduction reactions. These are common in organic chemistry and they can be identified by changes in the number of oxygen atom at a particular position in the hydrocarbon skeleton, or the number of bonds between the carbon and oxygen at that position. So depending on that, we can call them as oxidation reduction reaction. If the number of oxygen atom is going on increasing means that's called as an oxidation. If the number of hydrogens is go on increasing means in the hydrocarbon skeleton, it's called reduction. So here an increase in either corresponds to an oxidation, whereas the decrease corresponds to a reduction. Conversely, an increase in the number of hydrogen atoms in the hydrocarbon is often an indication for the reduction. So when you notice this box, here I have given the oxygen containing organic compounds. We can see that the arrow points out towards the oxidation and reduction. In oxidation, what happens? We are taking the starting material as alkane, and here the oxidation number of the carbon is -4. And here, when it is oxidized, it is converted to alcohol. When a hydrocarbon is oxidized, it is converted to alcohol, and in the next stage, it may be a carbonyl compound, especially it's a ketone, and further oxidation, or it may be oxidized to carboxylic acid and totally lost carbon dioxide, in which the carbon is having the oxidation state of +4. So when you notice the oxidation state of carbon from alkane to carbon dioxide, it is going on increasing, -4, -2, 0, +2 and +4. So we can notice that here oxidation occurs in carbon atom. So that oxidation reaction. What's the reduction? The reverse process. +4 to +2, 0, -2, -4, wherein which the carbon is having the oxidation state of -4. And the next slide, the first, not the next slide, in this slide also we can see oxygen containing organic compounds A, and the below table that is for nitrogen containing organic compounds. We have taken primary amine as an example, the primary amine in which the oxidation state of carbon is -2. When you calculate it, it is -2. And if it is an imine, imine means R2C double bond NH, imine. Okay, ethylene, carbon nitrogen double bond, as well as the amino group is as the secondary one. So it's a imine in which the carbon is having the oxidation state of 0. And when you come to nitrile, you can call them as cyanides, RC triple bond En. Okay. So +2, the oxidation state of carbon is +2. Here also from amine to imine to nitrile, the oxidation state of carbon is more, going on increasing, so that it's an oxidation reaction. Reduction is the reverse one, in which the decrease in oxidation number. So in this model, we have clearly seen what is substitution, what is elimination, and what is addition, and what are oxidation and reduction reactions we have discussed. Okay. It's a very simple model, you can watch and learn something. Thanks for watching this video.